Hi, it's Miss Austin. I'm going to be going over the lesson 14 practice problems. These begin on page 169 in your book. The first problem says, we know these things about a polynomial function f of x. It has exactly one relative maximum and one relative minimum. It has exactly 3 zeros, and it has a known factor of x minus 4. Sketch a graph of f of x given this information. Okay, so I'm going to start with the fact that I know that's a factor. If x minus 4 is a factor, that means the 0 is at x equals 4. It also said it has a total of 3 zeros. So that's an x to the third. So end behavior is going in opposite directions. I'm just going to go up to the right and down to the left. And it says it has one relative min and max. So in my head, ahead of time, I'm kind of imagining that it's going to look something like this. It's going to touch 3 places, and it's going to have one relative min and one relative max. Where I put those other zeros doesn't really matter. And I'm just going to make up a couple of places here. Okay? And then it's going to go up, down, back up. There's the relative max. There's the relative min. It's got 3 zeros, 1, 2, 3. And one of the known factors was x minus 4, which means it touches at x equals 4. That's just one possibility. There's many other possibilities as long as it has 3 zeros and one of them is at x equals 4, as long as it has one relative min and one relative max. Okay, my graphs a polynomial function, f of x, that has 3 linear factors, x plus 6, x plus 2, and x minus 1. But she makes a mistake. What is her mistake? So just above on number 1, when they told me x minus 4 was a factor, I knew that 4 was a 0. Whatever makes that factor 0 is the 0. So for this one, it's going to be negative 6, because that'll make that 0, negative 2, and positive 1. And you can see her mistake. She graphed the zeros at the numbers that were in the parentheses, right? She graphed it at positive 6, positive 2, and positive 1. So she had the zeros with wrong signs or backwards, right? However you want to say that. It should have been x equals negative 6, x equals negative 2, and x equals 1, not 1, 2, or negative 1, 2, and positive 6. Okay? It's whatever makes the factor 0. That's where your zeros are. Okay, that's number 2. Number 3. Here's a graph of a polynomial function with degree 4. Select all statements that are true. Okay, well, it's 4th degree, right? Both ends are going up. So A, the leading coefficient is positive. That would be true. Because if it was negative, then both ends would be going down. Okay, a positive with an even degree, which is 4th degree, both ends are going up. The constant is negative. The constant is your y-intercept. So here's your y-intercept right here. That's clearly not a negative, so this is not correct. It has 2 relative maximums. That's the only relative maximum I see. I see 2 relative minimums, but not 2 relative maximums, so C is not right. It has 4 linear factors. Let's go see the factors. 1, 2, 3, 4. And are they linear? Remember, if they only count once, then they go straight through. If they were, if they had a multiplicity of 2, then it would behave like a quadratic at that, and it would bounce off of it. These all go straight through. So that one is correct. It has 4 linear factors. E, one of the factors is x minus 1, which would mean it touches at positive 1. No. One of the zeros is at x equals 2. Yes, true. There is a relative minimum between x equals 1 and 3. Well, here's 1 and here's 3. They're saying somewhere between there, the relative min occurs. No, the relative min occurs like at 4 or -3. Disagree. A, D, and F. Question 4, state the degree and end behavior of the polynomial. Explain or show your reasoning. So first time I looked over this, I didn't pay very close attention, right? We can't always assume they have it written in the proper order. The degree is the highest power. So it looks like this term, right? If you really wrote it in descending order, it would look like this. Okay. But so that's the degree. And then the end behavior, okay, so an odd is going either like this or like this. And how do you know which way it goes? Because of the leading coefficient. Well, it's a negative. So negatives go up to the left, down to the right, right? And so remember, this is kind of a lot of writing, but so I know it's this one. So imagine as you walk to the right, as you get bigger and bigger for x, y gets bigger and bigger in the negative direction. And then as you get larger and larger in the negative direction for x, y gets larger and larger in the positive direction. So as x gets larger and larger in the positive direction, y gets larger and larger in the negative direction. That's as I'm going to the right, as x gets bigger and bigger in the positive. Now, as I go to the left, as x gets larger and larger in the negative direction, just to the left, y gets larger and larger in the positive direction. And remember, the only thing you really change there is the way y behaves. This part of the sentence, as x gets larger and larger in the positive direction, you always say that. You always have to consider when you go to the right, and then you always have to consider, well, what happens when I go to the left, which is getting larger and larger negative. All right, number 5. In this graph of g of x, is this graph of g of x, which is x minus 1 squared times x plus 2, or h of x, x minus 1 times x plus 2 squared? Or explain how you know. Well, this up here, this multiplicity, remember, that tells me how it behaves. Both of them have the right zeros, correct? So this touches at 1, yeah, and -2, same here. But remember, look at this one, the way it behaves. It's going straight through like a linear function. So that means it only counts once. See how this one has a 2 on it? And here it only counts once. And then this one, look, at 1, it behaves like a quadratic. See how it looks like a quadratic or it bounces? That means it has a multiplicity of 2. So it has to be g of x, right? Because this factor is squared and this one is linear, not the other way around. Number 6, Kieran thinks he knows one of the linear factors of p of x after finding that p of 3 equals 0. So he suspects that x minus 3 is a factor of the polynomial. So he sets up a diagram to check. So he wants to divide x cubed plus x squared minus 17x plus 15 by x minus 3. What is his mistake? Well, right here. I mean, x minus 3, I know 3 is the 0, but when you're doing the division, you put the factor, which should be x minus 3, not positive 3. So the mistake's right there. That should be a negative. That's why it didn't come out. Okay? And how can you tell it doesn't come out? Because, I mean, look here, 3 and 4 don't make 1. 12 and negative 5 don't make 17. When you do the division, if it is a factor, it should come out to this polynomial. All right, last one, number 7. The polynomial function b of x has a known factor of x plus 2. Rewrite it as a product of linear factors. You have a choice here. You could do the diagram or box method, or you could do long division. I'm going to do the box. So I want to divide b of x by x plus 2. So I'm going to put that in box. And then right? And I know the very first term is going to come out to be x to the third. Use a different color. So what do I have to multiply x by to get x to the third? X squared. Now I can go ahead and multiply these. That's 2x squared. Now I know that the x squareds add up to 8x squared. So that means I need a, I don't know why I only used red one time. Oh well, 6x squared. Now I can put, that would be 6x. X times 6x makes that. 6x times 2 makes 12x. Now I know that the x terms have to add up to 5. So I've got 12 here. That means I need negative 7. So that'd be negative 7 to make that. That'd be negative 14, which is what I'm supposed to get. So now I have x plus 2 times this, x squared plus 6x minus 7. Okay, I'm only partially done. It wants linear factors. That one's linear, this one is not. So this one can keep going. So you can either do the box, or hopefully, if you've been doing the homework and the activities we've been doing in class, we've found out that when it is just a 1 in front of the x squared, the two numbers that go in here are those two numbers that you use to solve your puzzle, right? You know this has to be x and x. That's the only way to make x squared. And now what two numbers multiply to negative 7 but add to 6? So two numbers that multiply to negative 7 but that add to 6. Well, 7 and 1 are the only numbers that multiply to 7. I need them to make a positive 6, so that's plus, that's minus. Now I have three linear factors. Okay, good luck on your test. Make sure you reach out to your teachers if you need help. Have a great day.